Hello, everybody. I'm here to talk about the evolution of agentic AI, and it's a hot topic in every industry right now, and telecoms is no exception. And that's because it's really going to change so many aspects in terms of the way we work, in terms of the way businesses are run and networks are operated. And AI is becoming something that we're all using in our personal lives as well. So there's a lot of expectations, if you like, being driven. So I'd like to start with some of the impacts on telecom. And there are many impacts, but here I list a few. So first of all, it will introduce the notion of a digital workforce that will work side by side with regular employees. It will make employees much more productive. They will have faster access to information and decisioning. They will be able to create code faster. They'll be able to do designs faster. And in addition, it'll also be used on the front end to really improve that much needed customer experience. The second key aspect is automation. I mean, we've been building more and more automation into telco networks for quite some time, but there are still tons and tons of gaps. So much is done manually. And agentic AI is going to really be able to fill those gaps. It's going to be able to advance automation, and it will also stitch different automation technologies and capabilities that exist today. And that's going to be incredibly important to make the business more agile, to make services more agile, and also to get that cost efficiency that's really needed. And ultimately, it's that competitive edge. Agentic AI will really help, not just to transform the customer experience, which we talked of, but the back end in terms of the systems and data needed for that front end experience, but also shift towards being able to do better services and be able to innovate more. So ultimately, it should be a driver for big business growth in the organization as well. So what I'd like to cover now is just step back a little bit and make sure we're all aligned on what agentic AI actually is, because it's an evolution of generative AI, and that's a technology that we're very familiar with now and we're all using, and it's been around for quite some time. And agentic AI basically builds off this, and it builds off it in a very important way, because essentially it centers around the notion of AI agents. And these AI agents are able to actually take on a number of tasks. Any number, could be a one task or two, could be many tasks. But the notion is it starts to make decisions. It's not being told what to do. It makes decisions. You can set it goals. It can take these actions. So it starts to act much more autonomously. And the reason it does this is because it's not just accessing a large language model to do its job. It's accessing a variety of tools and data points to be able to reach those decisions. So, for example, it could be accessing real-time data from BSS, OSS systems like latest inventory data, or it could be information from customer systems. It also might use decisioning tools to help it sort of, come to a logical conclusion. It may use the outputs from predictive AI, like a churn analysis report or something related to an anomaly detection that happened in the network, and therefore what you can do with that. So the point is that you define these agents and give them a set of tools and data points to do the task at hand, and they will access those when it's needed. And this makes agentic AI incredibly powerful. It can interact with humans, and it can also interact and be prompted by systems as well. So that's essentially what we mean by agentic AI. But maybe what we could look at now is some of those agents. What does it mean to have an agentic AI agent? Now, here are some of the agents that we've built in Netcracker and are using with our customers. So these are real agents that are really making an impact on the business. So, for example, you can have a customer service rep, contextual agent, and the whole point of this is it's helping the human agent. So when there's a call to the call center, the digital agent or the AI agent is actually listening to that conversation. So it's not being asked to do anything, it's just listening. And based on what it hears, it understands that the customer needs information on billings. Okay, so I'll pop up the billing records and I'll quickly do an analysis to see if I can find that information that the human rep can give to the customer. Or it could be to do with information on some, changing an offer or a new mobile device or a payment issue. But the point is they're constantly listening to that conversation. So it's very proactive. There's a B2B customer agent. Now, this is more aimed at the smaller businesses where it's very, very difficult to have human agent or human employees, if you like, scale for the enormous amount of small, medium enterprise customers there are. So these agents are able to solve reasonably simple issues. For example, if you want a quotation for 10 more SIMs because you've added some employees, or you have, again, some billing issues, or maybe you need some, sort of troubleshooting sorted. So there'll be a set of smaller agents assigned that will be able to fix these problems. Then if we think of a larger enterprise, we have an order to catalog agent, and this can be extremely powerful when you have very, very complex offers that are putting together for partners and for enterprise customers that are very customized. You have to work together and negotiate on all the different details of these offers. And in this case, the agent, once the offer is getting closer, the agent can make sure that all the details are in these documents that will then allow it to go off and automatically populate the right areas of the product catalog in the back-end systems of the telco to basically save an enormous amount of time that it typically takes to do this. Then on the right-hand side, we have an order resolution agent. Now, this is an incredibly powerful agent because when an order gets placed, especially if it involves appointment with customers or maybe delivering some equipment to a site like a new SD-WAN access device, some things can go wrong. And when it goes wrong, it's very difficult in the chain to figure out what to do next. And these agents are constantly monitoring each aspect and understanding what the problem is and then working a resolution, which may involve going back to the customer and perhaps checking that they don't mind having a slightly different variant on a device that they may have previously ordered. So that's a very powerful agent. Then we have the service design agent. This, again, a very, very powerful agent that saves so much time when you want to put a complex design together. You need access to many design tools, if you like, and you also need to understand what's happening in the runtime side of the operator network to make sure that the design you're putting together, if it's accepted, can actually be delivered. So it dips into different parts and different systems to make sure that can be fulfilled when the time is ready. And then the last one I describe here is incredibly useful one that many customers are interested in to really help correlate the problems in the network. So do that root cause analysis and find out, what went wrong. Again, looking into many different systems and being able to provide that resolution. So some everyday examples we're using now, very practical examples. But what I'd like to cover now is actually how you can measure the KPIs from these types of projects, because ultimately, this is what matters. Agentic AI is only going to be useful in service provider networks if you can measure it and if you can find some real business benefit from that. So I want to share with you some results that we are working on and getting with our customers right now. The first one relates to the call center calls. We can, reduce those by 40% because most of the call center calls are actually quite simple requests, billing requests and, wanting information on different types of tariff plans or wanting, information on perhaps your moving address and you need to understand the procedures to sort of change to a new home address. So all these things can be solved very quickly by relatively few agents, and these are the kind of results that can really save costs. Also related to more complex invoices, where again might be a large enterprise, might be a wholesale partner, you can save up to 70% of time resolving these complex issues, because these invoices are hugely expensive. By having agents be able to sift through that data, compare with previous invoices, understand different dynamics that are happening, understand the contract, understand whether the customer is the kind of SLAs that have been contracted with that customer, you're able to come up with different resolutions. Has there been an issue, or how to go back and resolve that? In terms of product catalogs and being able to automate the provisioning, if you like, of these catalogs, you can sell 12 times faster to be able to do this with these agents, and also 7 times faster to do these service designs, which can save a considerable amount of not just time, but obviously resources, so that you can progress and serve customers much faster. And then another compelling one on the network side is being able to reduce or let's say increase the speed of finding faults by 80% together with a resolution, by again having agents that are able to correlate in real time across different systems to find the right resolutions. So very compelling results. Now, what I'd like to talk about now is some of the challenges, if you like, in getting to the stage where you're actually deploying and scaling agentic AI, because there's many things to consider and there's many hurdles. And we've been working with service providers for the last couple of years, so we kind of really understand some of the pain points that our customers have been going through, and we've helped resolve. And the first one is justifying that return on investment, because ultimately you can create any fancy demo, have a wonderful avatar experience, but if you don't understand how to deploy that and scale it in the network, then it may not be a viable use case. So that's something that's worth really spending the time on, and understanding the use cases, the roadmap, and how it impacts the employees in the company as well. Second are the data and tools, because obviously with using large language models, it's not so much about having the data in the right format, because it really doesn't care, but it has to be correct data, it has to be good quality data. And as we know in telco networks, there's still many transformations that still need to be done, moving, for example, inventory systems from legacy to modern systems, consolidating product catalogs, consolidating the numerous billing systems that you get in some provider networks. So these steps are essential to be able to get accurate and clean data, and then make sure it's maintained as well. Then we have the trust and governance. Of course, this is crucial, because many service providers out there will not be using their own private models. They will be using more commercial models, because the private models are still extremely expensive to run, require obviously a lot of hardware to run and compute. So using those public models requires an extra levels of security to make sure that none of your customer data is being exposed. The threat of cybersecurity and others is huge at the moment. So this is a real attention area. And not just security, it's making sure that the model and the agent is actually doing the right thing. It's giving the complete right answer. There's no point in having this technology if it's just right 30% of the time. And then finally, to that scale, how do you go from 1 or 2 use cases to having many? How do you make sure that the vendors all work together? How do you avoid having to build from scratch each time, or have multiple platforms, and make sure that you can replicate as needed and grow the business as needed? So these are some of the challenges. So let's talk about a few of these, and one I'd like to start with is actually the return on investment, because this is so critical to get right. And this is something we spend a lot of time with our customers up front before we get to the agent design process, where we're really making sure the use case is right and the return on investment is right. So first you define, what are those use cases and what benefits do you think you will get? And then the critical piece comes in where you understand, but what's your environment like? Do you have the right inventory data to support this use case? Do you have the right information in the various catalogs that you have to support it? Is your customer information systems up to date? So it's important to know that the use case has the right environment ready. And if not, what will it take to get it ready? Is it a small job? Is it a huge job? And also, what's the automation environment like? Some of the use cases on the OSS side may require you, for example, to have a closed loop environment. If you don't have closed loop, maybe you can't do some use cases like root cause analysis, because you haven't actually got the right environment in place to make it happen. So it's understanding the use case, it's understanding the environment, which even goes to choosing the right models and making sure the right skill set is available and the resources are available to do this. Then it's possible to pick the right use cases, start to test them, and then once you've tested them, you can measure those results and check that it's actually realizing its potential before it goes into the kind of real production environment. So very, very important process. Then I'd like to talk about the agents themselves, because the agents are, you really require a lot of knowledge and expertise to be able to build them correctly. And what's important is to make sure that the scope of the agent is not too broad so that it's going to start hallucinating and giving you incorrect answers. And the key here is to really understand what it is you want that agent to do. You have to understand the telco business processes. You have to understand how they need to be re-engineered or change or be made, frankly, more dynamic, because now it's not going to be rule-based anymore. You're going to, you don't know what's going to happen next, and these agents need to be prepared for that. So being able to scope out and define these agents and give them the right instructions and the right data and the right tools to do their jobs is absolutely critical. And then you also have to know how to unlock that valuable data that's in these BSS, OSS systems and data lakes that will be essential to build really high value use cases. A lot of the static data that's available is not going to be the data that really moves the needle on this agentic technology being very transformational. The transformational piece is when you get access to the real-time data so that you can set these agents off to make their decisions to achieve these goals and do it in a very autonomous way. And you need to make sure these agents can be orchestrated with others from different companies, of course. And that's why there's protocols now that are in place. We have protocols called MCP that allow you to access data and tools in a more standardized way, in an AI native way. And there's protocols like A2A and other emerging ones that allow agents to talk to agents in a more standard way. So adhering to these kind of new protocols is very key too. Now, agents can't run by themselves. They're just essentially little programs that basically need a platform. And the platform is the part that's very key, because the platform is the part that really makes sure that you've got the right security in place. You identify all the confidential data and you're able to obfuscate it. You're able to put the right governance levels in place and monitor it. You're able to do all the analytics around the performance of an agent and the performance of a model. And you're able to understand what the agent did so that you can trace it and make sure that it was the correct way of doing things. So all these aspects are very important. And the platform gives you this, as well as the ability to orchestrate across many agents. It will keep some memory so that the context of the different interactions, if you like, can be kept from one to the other as you build higher and broader level use cases. And the key with the platform, it should work with any LLM. There's a whole host of LLMs that exist today that are incredibly powerful, very different cost points. Some are good at doing everything, some very specific at certain tasks. And it's important that the agent is chosen for the particular use case, or multiple agents for a use case, so that it's keeping that cost within the what's required to make the business case work. You also need to work with any channel. So it's about building out the agent through a certain channel. Is it a chat session? Is it a nice fancy avatar? Is it a voice session? Is it coming through an internal workstation? And what does it look like? And representing that through the different channels is key. And the platform gives access to, through a set of APIs or these MCPs, access to different tools. So this is very, very critical as well. And then towards the last thing I want to talk about is the importance of orchestrating agents in different ways, because the first use cases that come out will have a small number of agents working together, accessing a reasonably small set of data and tools. So we'll be on the left-hand side, we show a very simple agent that actually just accesses one or two data points. The middle one is where we have an agent that's like the master. So it's in charge. It works with the end user or it works with a system, but it chooses which other sub-agents it works with to do its job and which tools it might need. And it makes that decision and it gets the right data it needs to fulfill the request. And then on the right-hand side, we move to a peering model. And the peering model is where agents can actually hand over to each other, maybe negotiate with each other. This is where we'll have a huge amount of intelligence going forward when it increases the level of autonomy, if you like, that these agents have. But before we get there, we have to do the first few steps and really understand and trust these models and make sure they're doing the right thing. So in summary, a few quick takeaways. We in Netcracker would suggest that you first of all spend time up front on really finding those right use cases that give you a high return on investment, so you can learn from those projects and start to build out more and more in the pipeline and improve the data availability and the automation technologies needed to do the higher level use cases. Always think and start with the longer term, because ultimately that's going to save you an awful lot of time and money than just building little silo projects where everybody's doing their own thing in the organization. Build those best practices so that then afterwards you can keep adding and replicating. Ensure that you have an open environment, an open platform. The platform needs to support any use case. It shouldn't be lots and lots and lots of little platforms. So make sure the platform is open for any agent, supports any of the variety of the models, it supports any of the emerging protocols. This is very important to make sure that you can continue that scaling, but also make sure the agents as well are open and can work with each other. We suggest not to make agents too complex. It's better to orchestrate them together for the higher level use cases rather than build an agent that's got so much information it's likely to go wrong. And obviously the context window in any large language model is not that great yet either to enable that to happen. And finally, think about the end-to-end, because it's the agent is one piece, but that upfront design in terms of understanding what to build and designing the right use case and testing it, through to all the work that needs to be done to integrate into the environment, and also what kind of user interface you want to present this through. And then finally towards the making sure it continues to perform. So hopefully that's given you a flavor of some of the things to consider to start scaling this technology. And if anybody has any questions, then feel free to contact me. Thank you very much.